Thank you all for coming. We're going to be talking a lot about detection as code. It's something I think a lot about. I've been doing detection engineering for the last 5 years, and then Namisha also dives really deep into it because she makes sure that we're giving customers in our product exactly what they need to do things like this. So kind of give you a little bit of background about me. Been doing detection engineering and response for the last 5 years. I ended up joining Datadog a year ago to focus more on the security research side. So what a lot of that looks like is threat hunting, understanding like current threats, attack paths, and then how we can build better detections.
Yeah, and I'm Namisha. I actually started, I guess I've spent majority of my career in security, but in the past 4 years, I've been building the security products at Datadog, so working with personas like Julie and making sure that they have what they need from a product perspective and build those for them.
Yeah, it's a team effort. So I'm going to go over a lot of the principles of detection as code, like how we think about it, and then Namisha's going to dive into how we've implemented it internally. So I think it's like a buzzword, right? You hear detection as code, it's like important, but then people don't really go into how they implement it, why it's important. So we're going to talk a little bit about that. I've worked at organizations where you're still deploying detections very manually, and that's great when you're in a small team, but it doesn't scale. And so when you're thinking about how do we enable a detection engineering team who has limited resources to ship quality detections and then also be able to manage them in a very reasonable way. So the way I think about it is we have this PR, we give engineers the ability to do very thorough code reviews in a very seamless way. Then we can deploy very extensive testing, and then we can actually deploy this to our SIEM. And also I would say this is great if you're using multiple SIEMs or multiple security products where you're deploying detections, because you're storing detections in a central place. And then you're able to say, well, I want to send this to be a query in Snowflake. I want to do this for my actual SIEM. And it gives you a lot of control over how you actually implement your detections. So some people might be familiar with this. This is kind of my diagram based on a lot of research that has come out from other practitioners about how they apply the software development lifecycle to detection engineering. I highly recommend this great article by Hyder at Snowflake. He used to run the detection team. And the way that you think about detection development is actually very similar to software engineering. And I think the more parallels we draw between software engineers and people that do DevOps, SRE can really help us increase both our posture and the scalability of our detections. So I won't go through every step here. I think some of them are pretty standard if you're familiar with the SDLC. But some very important aspects of it is, I think, defining requirements and how you approach design. So there's a lot of steps you get to before you actually write the actual query. And for our team, we focus a lot on what is the best approach. Can we prove that this is a path that an attacker would take? Have we seen it in the wild? How do we actually want to build the query? So what thresholds do we want to define? Do we group a bunch of anomalies? There's all these design aspects, and sometimes the outcome of design is that you're going to deploy multiple detections for the same attack path so you can best evaluate them. And so all of this goes into development. We have the testing and deployment we'll talk about. And then really thinking of this as a cycle. So once you deploy a detection, it isn't static. You need to review it like code. You might need to refactor it. You might need to update it if log structures change. If your attack surface changed and it's no longer relevant, maybe the alerts are blowing up because of a new process that IT has implemented or the infrastructure team. So these are ways to think about detection engineering and continually improving them outside of just your SOC or your analysts are upset about the noise, right? So there's things you can do to make sure that both the detections are working properly and being reviewed continuously, as well as they're not blowing up for your analysts. And so some of the main challenges I hear from other detection teams that I know is they don't have the centralized version control, audit history, understanding of where their detection was in a point of time, and really being able to track the growth and the changes of those detections which you get when you're centralizing your code in something like GitHub, you really have inconsistent quality because it's harder for each of those detections to be reviewed. So you might have one person on your team that like approaches a detection in one way, another person that approaches it another way, and you don't get to share that knowledge and like understanding of how you want to approach detections as a team. And that leads into the siloed development and then the hard to manage at scale. Again, how I mentioned, like a lot of teams have multiple solutions they're using, and understanding what is deployed to what, how you can easily search your coverage, and like what is being deployed. So I put a lot of memes in this talk. But thinking about detection as code, there's some aspects of manual engineering that you do a detection that you're not able to track fully. So if you're deploying a detection, you're not doing continuous testing, you're not monitoring, you actually don't know if the detection's working as you expect it to. And then an incident happens, and you're like, but I wrote a detection about this. And then you realize, oh, again, the audit log changed, or the threshold wasn't working as expected, or something in the query language changed. There's all these things that you need to think about continuously to have effective detections. And the worst thing you want is an incident happens, and then they come back, and you're like, yeah, the detection didn't work. So kind of the parallel to some of those manual engineering issues, you get the benefits of that peer review, being able to do extensive testing, however you want to set up testing in your environment. There's a variety of ways that you can do this, depending on the maturity of your team. You get those like benefits of deployment, just like software engineers do. And then really the reusability has been a big thing for me. Understanding a detection engineer that I work with built out this really crazy complex query that is amazing. And like, I don't have to go through just starting from scratch when I'm also looking for a similar attack path. But if that was deployed in the SIM, it would be really hard to find and pull and understand. So just being able to search GitHub and get everything I need and really speeds up detection engineering time. So this is a screenshot from a Sigma rule, which is the most common open source detection language and then also repository. But one thing I really liked for deploying detection as code is you can actually inlay all this metadata into the code that you're storing in your repository. So things like references, even playbooks, when it was modified, when it was updated, the last time it was tested, what the deployment looks like right now. Is it in production? Is it in staging? You get a lot of really good context that like is up to your team to add, and you have the power to include this in a way that if you were navigating a SIM UI, you wouldn't really have the ability to build your own context. So again, with the open source rules, you know, Sigma is the biggest plug. Everyone uses Sigma, or has at least looked at it. So the one thing I want to call out with open source repositories is a lot of these detection as code queries that are available, open source, Sigma, et cetera, Elastic, you're able to understand the coverage, that basic detection coverage that a lot of other companies are deploying. And then you get to shift your time as a detection engineer into things that are really critical and unique to your environment. And that's where you get like the really interesting problems. You can tell leadership that you have visibility into these things and really prioritize your time in a way that tailors it to your organization. And then one thing I just wanted to mention is there's a site, I think it's a couple years old. It's called uncoder.io, if people aren't familiar with it. But it allows you to convert detection queries to other languages, very popular, like SIM languages, et cetera. So then if you're approaching, you see this open source repo, and you're like, wow, this detection's amazing. This tool might be able to help you convert it into a language that you're actually using. So I highly recommend checking it out if you're thinking about adopting some of these open source rules. Okay, I'll hand it off to Nimisha.
All right. So yeah, now that Julie has sort of laid out all the foundation and how you could potentially, benefit from detection as code, let's dive a little bit deeper on how we actually do that internally at scale at Datadog. So how we write these rules, how we deploy them, how we test them, and all that fun stuff. So our development pipeline really just starts like any other software engineering teams would, which is GitHub, right? So detection engineers go in, they write these rules, they write it in code. Every change that goes into these rules, there again goes through the pull request process for peer review. So all these PRs get reviewed, and then they get merged. So the moment that you cut a PR out, we have GitHub jobs that kick off right away. So these include linting, so checking the syntax of the rule. We look at validation, so making sure the rule can actually pass through the API for Cloud SIEM. And finally, deploy it wherever we want. So at Datadog, we also have multiple instances, so we want to be selective and make sure that we deploy it at the right spot. And everything, again, from rules to suppressions to automation workflows, they are all managed as Terraform resources that really helps us with consistency, repeatability that Julie just mentioned, and then they get finally deployed in prod into Cloud SIEM. So let's take a deeper look at how we actually go through the entire process. So every engineer starts in the UI. This really helps it easy to write those queries, those really long, complex queries. We write them in the UI itself, and with a simple button, we're able to sort of export it as Terraform files. Once we take those Terraform files, we look at a lot of standardizations in our format. So things like tags are very important for our teams to maintain MITRE attack tactics, techniques, to then, I guess, look at the detection coverage that we have overall throughout those rules that we deploy. And then we also look at our query. So these queries really help us understand what's the actual search that we're running and what the logs that are going to match to this rule. And they're all, again, wrapped in this Terraform resource. We also look at the message, which is really our detection playbook. So we look at our detection strategy, why we wrote this rule, how our responders can actually take this context and run certain actions from there, and all the blind spots to look out for, really just the why behind the rule that was written. And then again, all of our templates, our PR templates, really help us to understand what the changes were made, how it was tested, what are some of the jobs that we ran internally, externally, manually, all that fun stuff, and then get that cut out and reviewed by someone on the team. So our GitLab pipeline is a series of jobs that we trigger. So once the PR is approved, our CI/CD pipeline takes over. From staging to production, it really just handles that end-to-end build process. So this automation really just helps, again, with human error and ultimately helping us, deploy rules faster. GitLab will here trigger a series of jobs, like I mentioned, in our CI. So this would, again, include linting jobs. It really just helps you look at the structure of the rule, check for any syntax, right? We also have validation that helps us, make sure that all the relevant fields that are required for the rule to get deployed. And then ultimately, the deployment really helps us figure out which instance we need to deploy this rule to, and I'll go a little bit deeper into that as well. We manage all of the rules that are deployed into, so DynamoDB, it really just helps us lock the state of that rule, and then S3 bucket is where we hold all of our state files. So here's where I wanted to talk a little bit about our multi-org deployment. So at Datadog, internally, we have multiple different instances that we manage for our SIEM. So this includes our prod, our staging, corporate, even gov, right? So really, Terraform just helps us, to make sure that we're able to select the different types of rules and make sure we're able to consistently either deploy it everywhere or selectively to one of these instances. And ultimately, this is where it's all backed by our SIEM API. We are pragmatically able to deploy, create, validate all of these rules, making the detection truly, code-driven through the API, the CloudSIEM API itself. And yeah, I'll pass it to Julie to talk a little bit about normalization.
Yeah, so at Datadog, this was a problem that we saw in that there's a different need for data normalization for logs that are coming in about infrastructure resources, applications that our SREs are maybe dealing with, and there's an entirely different approach to data normalization for security engineers. It's really important that we have consistent fields that we can write detections against, we can speed up incident investigations, and really being able to better understand the data. And for us, the facets and the fields we were building on the software engineering side for people that use Datadog for observability just really didn't work from the security perspective. So we wanted to pitch and build this unified data model. And so as I mentioned, the unified data model has a lot of key benefits. And I think one of my favorite out of this is also just the data reporting and visualization that's possible. So when you're building these graphs, you're understanding your coverage, what alerts are firing, you can actually dig into the individual fields and understand alert noise, actors that are taking multiple actions that are triggering multiple alerts. You can build these better visualizations and graphs to both speed up your security analysts and take those visualizations and use them for leadership. And so I'm sure people have seen this one, it's pretty popular. But there's this idea that everyone wants to create a unified data model structure that security engineers use. So there's so many standards, I'll go into them, but then every vendor keeps creating a new standard or maybe open source, and a lot of ones that are open source are influenced by vendors. So you just keep seeing these standards being created, and you have to understand what is the best for you to adopt, and then also what meshes the best with the security tooling you're using. So I'd say these are probably the 4 biggest ones I've seen people using. Elastic has been around a long time. It's a very common one, especially if you're using Sigma rules. Obviously, if you're using Splunk, you're going to be using the common information model. A lot of Splunk partners will also adopt this or have this as an available option. AWS has been doing the Open Cybersecurity Schema Framework, which has more of a observability SRE logging focus, especially for AWS logs. So it's highly influenced for people that have AWS environments. And then Chronicle also came out with a unified data model as they were running into the same issues that some other vendors were running into. And so we spent a long time trying to figure out what the best unified data model is, and we didn't want to create a new one, either open source or Datadog. So we evaluated internally, and because we're so heavy reliant on AWS and we focus a lot on CloudTrail, a lot of cloud environments, and also being able to map fields from one cloud environment to another, we ended up choosing OCSF. So some of the key things about OCSF is while it's influenced by AWS, you can take the current log fields and you can still map it to standardized classes and fields. So you still have a lot of the flexibility of a traditional unified data model. You can then integrate OCSF into your logging pipeline. So as your logs flow in to your environment, you're actually transitioning it into OCSF in a standardized way. A lot of people think about logging pipelines. Some people just pipe logs directly into their SIEM, whereas other people maintain logging pipelines where they can do enrichments inline, they can drop certain fields, add certain fields, et cetera. So if you are doing it this way, you can actually adopt OCSF in the pipeline, or another unified data model might come with your security solutions. And then another thing about OCSF or other unified data models is just being able to test the schema, understanding if this is actually going to work against your logs, what fields are going to be populated, et cetera. So you have, as a detection engineer, full visibility into what your logs are going to look like and how you can write detections across sources. So this is one example we did where we were looking at GitHub logs, and then we're mapping it to those OCSF fields. So that way, if we're looking at GitHub logs versus GitLab logs, or even across unrelated sources, you can then chain detections together and have quicker investigations when you know actor.username is always going to be present, and you don't have to say, I'm looking at actor here and username here and identity here. So you get like that faster investigation time, but also the simplified experience for detection engineers. So one small step in data pipeline engineering is one giant leap in general. So manipulating data pipelines, working with log ingestion is one of the hardest problems for security engineers, both from getting logs, understanding when logs drop, storing logs, the expenses of storing those logs for a long time, understanding when you keep them in hot storage, when you keep them in cold storage, et cetera. So really having a centralized strategy and this unified data model helps in a small way to better your overall data engineering pipeline.
All right. So on to our favorite topic, probably not, but testing detections. It's painful. Sometimes it leads to, something was missed, and we all have been in a position where I didn't check a syntax, or I wrote the field wrong, and then all of a sudden I have 1,000 alerts being generated in my SIEM. It's never fun, and the cleanup is not great. So just wanted to talk a little bit about testing detections. It's something that even I, as a product manager, we have been working with a number of customers. They always say, hey, what can your tool do to help us with that? It's a combination of what the tool can offer you, but also the practices that you can embed in your detection engineering process. So let's go a little bit deeper into that. Just wanted to start a little bit with the key benefits. Really, again, you want to be able to validate. You want to be able to look for accuracy. At the end of the day, we're all trying to detect that one thing, and you want to make sure your detection allows you to do that. Ultimately, reduce the number of false positive. That's a given. Every detection that we write, we want to be able to keep fine-tuning it and make sure that it, again, reduces the number of alerts I need to triage for it. And then ultimately, also, continuous development is another piece here, based on feedback, based on the number of alerts, the metrics that we got from that detection. You want to be able to go back and then test it again and go through that entire process and do it at scale. So I'm going to go into a couple methods, again, from a tool perspective, also from a practice perspective, that's helpful in testing. So we look at 4 angles here: unit testing, dynamic testing, impact analysis, and finally attack simulation. So starting with unit testing, this is really just your first line of defense. You want to make sure that your logic can run on synthetic logs. Sometimes I'm writing detections for stuff that has never occurred in my environment. I don't know what the log looks like. I want to be able to take a sample log and run it against that detection that I just wrote, right? So to make sure, again, the query works as intended. So think of it as like a sanity check before anything goes even further. Then we look at dynamic testing. So this, again, by no means this is something that we follow internally very well, but this is, again, these are practices that we want to be able to get to. There's this step that helps you sort of, look at the logic inside our SIEM, make sure it goes through the entire CI/CD. I showed you how we do that internally at Datadog, and then we want to make sure the syntax is fine, functionally the logic really works, and it confirms that both those internal and external factors will make sure that the detection will work as intended. Going into impact analysis, so this is something that I've even from a tool perspective, I've been working with a lot of customers on. Users come in and they say, hey, I have all this data, all this telemetry that lives within Datadog. How do I use that to improve my detection, right? You want to be able to take that detection that you wrote today and run it on past X months of data that's been sitting in your cold storage, hot storage, or whatever that means, right? You want to be able to run it against that and see how many alerts would have triggered. Did I miss anything? Do I need to, escalate those results that I got into an actual alert in my environment and get that triage, right? So understanding the impact before really moving the detection from testing into prod is super, super important. And even with Cloud SIEM, you're able to run a simple historical job that says, hey, I just wrote this rule today, run it on past 6 months of data that lives within Datadog. So yeah, incredibly useful for tuning and making sure that you didn't miss anything in the past. And finally, attack simulation. So here at Datadog, we have a dedicated team of security researchers. They have developed these open source tools. So Stratus Red Team, Atomic Red Team. What they really help you do is simulate an attack in your environment. So what that means is a series of logs, a series of events that occur in a specific pattern that would simulate what an attacker would actually do. And then you can take your detection and check if did it trigger for those actions, for those logs that came into my environment. And this really helps me, again, to check if the rule would have worked tomorrow if the attack was actually real. There's a lot of other open source tools. You can also work with your red team on these type of practices. But yeah, again, it's just means of us trying to be as proactive as possible before taking any detection into prod. And I'll give it to Julia to talk a little bit about strategy.
Yeah, so I think monitoring is a hard part. We're very constrained by resources as a typical security engineering team. And once you deploy detection to production, you're not necessarily thinking about how do we monitor it, unless, of course, you get a ton of false positives and like alert fatigue from your SOC. The detection kind of just sits there. And so building a process, whether it's manual with like Jira or it's like automated by flagging different like past pull requests and versioning, is really important to make sure that those detections are staying accurate for your environment and they're useful for the purposes you need them to be. So for monitoring, you can do detection reviews. I think this is a more manual process, but it's really important depending on your organization. So maybe you have the person that is on call, or like sometimes they're called goalies, or like the assistance person for other teams' asks or like ad hoc projects. Maybe they're doing that position for a week, and then if a detection has been in production for longer than 6 months, they get a ticket or like they get a ping, and then they can re-review it. That's like part of their like operational job. Again, not perfect, but different organizations have different resourcing. So sometimes people just do like a bug bash, like a little hackathon where they spend time, the whole team, looking at past detections. But having some sort of process is really important because otherwise they get stale. Also considering detection decommissioning. This is like a discussion to have both internally on the detection team, understanding what detections are still useful for you, but then also engaging the SOC or whatever security analyst team you have. Because if they're getting pummeled with an alert, they're either going to come up to you to tune it, or you have to make the valuable decision if the alert is even worth keeping in the first place. And then last, I just want to like talk about improvements. So when you have one detection engineer create a query for a detection, maybe they did it through a GitHub repo, through a pull request, other people reviewed it, or maybe that detection even existed before anyone on the team, like current team, was there. So understanding from your perspective where you come in, you understand the current technology, the current way the company is working. How can you make that detection better? How can you make the playbook better? Is the logic still relevant? You can use your expertise to improve maybe some foundational work that was done before but has not been maintained, et cetera. Really making sure that those key security events don't fall through the cracks. So some key takeaways to all of our yapping is, why would you adopt detection as code and a unified data model? So these are like the two key aspects to actually doing detections at scale. As your organization grows bigger or your team is small, these are the best ways we found to make sure that you are empowering your detection engineers and making sure they're both writing quality detections, able to focus on important things, and not spending all their time on like minute details. So normalizing the data allows us, for example, to write a detection that might be focused on an AWS behavior, but that same behavior occurs in GCP, and we can write across telemetry detection. We can also do more efficient threat hunting and detection analysis. So that normalization piece has been the biggest game changer for us. And then, as I showed in the beginning, there's the standard detection development lifecycle that is mimicking the software development lifecycle, but really taking that and understanding what it means for your team and how you're going to approach each of those facets, or you're going to prioritize them in your switch to detection as code. And then, as Nimisha talked about, the testing mechanisms are really critical, and you're empowered to do that when you're doing detection as code. So being able to, one of my favorite is like, so you make a pull request, and then, for example, an impact analysis runs on, our past like 2 months of data. So then you know if you push this detection, what is the noise level that your analysts are going to feel? What are they going to be seeing? And you can really make a strategic decision as a team. Does this need more tuning? Is this good enough for our environment? Do we keep it in testing longer? And so you really get that visibility in how to make the highest quality detections, especially if you aren't the one triaging them. And so just like overall, we're going to talk about some next steps that you can take to adopt this in your environment. But if you get anything out of this talk, I just want you to know that these are two critical aspects to just being able to have a detection engineering team that has both a good quality of life and can scale very quickly. So if you want to implement this in your environment, there's a couple different ways you can go about it. Nimisha's going to talk about how you would do it at Datadog, and then I'm going to talk about some open source alternatives.
All right. So let's connect all that we learned, all the dots, and see how that really comes together in Datadog Cloud SIEM. So with Cloud SIEM, you can build, you can test, and scale your detections using the automation and really the detection as code strategy that we just talked about today. So we can lint the logic, you can run unit tests with mock data, you can back test with real data that's already stored in Datadog. Then you can go in and convert those rules into Terraform for standardization, deploy them via Terraform and or just the API into your live environment, and then ultimately track everything through version control. And all of this is fully automated. All the system is designed for you with each of the APIs available in the tool. And hopefully that really helps with managing those detections at scale. And I'll pass it to Julie to talk about the open source.
Yeah, so going through each of the steps that we kind of talked about, the critical infrastructure that's needed to implement these things, you can really approach it in a lot of different ways, but I just wanted to give some examples of how you could do it on like a really low budget or using open source tools so you don't have to worry about like how you're going to maintain it and things like that. So an example is Wazoo SIEM. I haven't personally used it, but I've heard good things. It's open source. There's plenty of ones out there where you can understand like your self-hosting. You have complete control over your SIEM. And then using something like GitHub repository. If you're using GitHub repositories, it's very easy to adopt GitHub Actions. So you can kind of use that entire pipeline. And then maybe from a detection, for example, because you have it deployed as code, you have metadata that associates it with an automation. So if that detection triggers, you automatically have a workflow system that will take actions or recommend things to analysts. So having this detection as code approach both links you into the detection engineering process to improve it, but also like the end experience for the analyst. And I've used Airflow in the past, really like it. And it also helps if engineering teams within the company are using it. And then you're able to like mind meld and like share code, but also just leveraging whatever workflow and automation tools your company's using internally. And also sometimes that means that you don't have to pay for a license, which is nice. And then you can do case management. So I mentioned GitHub issues here. I've seen people use it in the past. It doesn't have the most features, but if you're already using the GitHub ecosystem, you can focus on just that entire life cycle. For example, a lot of people use Jira, and they already have licenses, the company's already using it, et cetera. So just whatever case management tool you can leverage, it makes the easiest process for your detection engineers. That's all we have to talk about regarding detection as code and a unified data model. But we're happy to chat if anything comes up that you want to talk about, or if you're wondering how you can deploy detection as code in your environment. Cool, thank you.